here at the Cloud and Data Center Convention event, and we are experiencing so many nice and new technologies in different parts of the data center industry, different fields of the data center industry. And it's a pleasure and an honor to be with all of you, all delegates who are here from their field of expertise and discussing this new technology in data center. To standing here today, we are computing so much data, and we don't know where the data is coming from. We have some data center in Navi Mumbai or Bangalore or Chennai, which is guzzling data and creating so much heat that we don't know how to dissipate and take care of that heat. How does one tackle that problem going in the future? You need to tackle that problem going in the future. So today, in the next 10 minutes, I'll just give you a brief idea of how data centers can actually tackle the heat problem by using efficient liquid cooling technologies. So this is the computing need of the world right now. We are at a computing need of up to 50 kilowatts. So if you see, all the technologies till now were at air cooling or heat exchanging. But now with the new AI loads coming in and the new compute of which is becoming higher and higher in the north of 100 kilowatts, air is not going to be able to take care of any of these compute. So what we'll do, we'll go to different modes of cooling, which is through liquid cooling, either be it single phase or direct to chip or complete immersion cooling with two phase. So that is how the world is going to process data and compute heat as well in the future. So where is the market today? We all ask this question, what are we supposed to deploy today? What is the market requirement today? We don't know that, but that answer right now for us is we are between a range of 80 to 130 kilowatts density per rack. That density can be taken care of by cold plates and direct to chip technology. So we have a cold plate, we have a CDU, and we have a piping network which will supply the coolant to the entire cold plate. That's how the current setup is. If you see, the global liquid cooling market is going to grow at a 27% CAGR over the next 6 years. It's going to reach a total value of much more than 10x of what the current market is. So it's going to reach approximately $10 billion by 2030, which I said is more than 27. It's a 37% CAGR. So in 3 years' time, from today, we are going to see that every data center in the country or across the world is going to be interfacing with some kind of liquid cooling, be it hybrid cooling with direct to chip, complete immersive cooling through single phase or dual phase, but there will be some kind of liquid cooling in each and every data center within the next 24 to 36 months. Now, when we say liquid cooling, everyone has different broad ideas about liquid cooling. How do you define it? There are three different kinds of liquid cooling that are there in the market. The first is a direct to chip system, which directly attacks the heat on the chip itself. So when you take a server chassis, 85% of that heat is being generated by the chip which is processing data, either be it a GPU or a CPU. How do you address cooling it efficiently? By going directly to the source of the heat and ensuring that that heat is dissipated in the most efficient manner. So over there, we need to have a CDU unit, which is a coolant distribution unit, which transports the technology coolant system, which might be a 25 polyglycol solution. And basically, it lets the chip get cooled through that, and there is a heat transfer which takes place at the heat exchanger. This can take up to 135 kilowatts per rack, which is a very good compute capacity in today's world because the AI loads that are coming and are defined are up to 100 kilowatts. So direct to chip is a very efficient system which can be added to your existing data center as well. So take a CDU, connect your chiller and put it into the CDU and start transferring the TCS. The second one, which is the most efficient and the technology for the future, is a two-phase immersion cooling. You can all see the setup at our stall as well, which basically uses convection, basic physics like a kettle of water, and it transfers heat in terms of boiling into vapor and back into liquid. That's very, very simple, closed loop, no water usage, and the efficiency of that system can go up to 252 kilowatts per rack as well, which is massive and unheard of. And the third one is single phase liquid cooling, which uses oil-based lubricants, which cool the dielectric, which cool the entire server and give you the efficiency of approximately 120 or 110 kilowatts per rack. Let's get into a little detail. This is the direct to chip system firstly. What are the components in direct to chip system? Normally, as a colo provider or a cloud provider or a data center provider, you will not be interacting with the first two because that is brought by the end client or the hyperscaler. If you are a hyperscaler, you define that as well. But in general, for this industry, we have to do everything after two. So 3, 4, and the entire CDU installation. So you will have a n+1 redundant configuration or a n+n redundant configuration basis your design. But basically what the CDU does, it transports the coolant system to the chip and gets the hot coolant back, and in the CDU there is a heat transfer with the facility water. That's how the basic CDU functionality is. In this case, you're getting a PUE of approximately 1.25, 1.26, which is already a 30% reduction to today's PUE in India. So it's a massive PUE saving, plus you're already computing 100 kilowatts plus in one single rack. This is what two-phase immersion cooling does. It's a great technology and so simple. What it does is basically we have a dielectric liquid which is completely fire-free and does not conduct electricity. What it does is when the chip heats up to 50 degrees, the liquid boils. The liquid boils, and as normal any liquid would boil, it would turn into vapor. When it turns into vapor, you have a small copper coil which is running over the vapor, which is transporting ambient temperature water. Nothing more than ambient temperature, nothing less. So you don't require chillers, you don't require crack units, you don't require pahos, nothing. You just have a dry cooler outside which is doing free cooling and transporting water at 40 degrees or 38 degrees. The vapor will interact with the coil and convert back into liquid like a normal convection happens, and then fall into the tank again. So the entire passive cooling that is happening is creating such efficiency where the electromechanical PUE of this system up to 252 kilowatts per rack is only 1.04. 50% savings in PUE. That is 33% savings in OPEX every year for a data center provider who has OPEX cost of multiple millions of dollars. Very simple system, just a tank, liquid, one pump to push in the water and a dry cooler. Nothing else. No false floor, no chillers. That makes your data center design much easier. Just to put it in numbers, if you have to design a 30 megawatt data center, you can do the entire setup of data center with all the services from ground plus 2 floors, compared to an air-cooled data center which would take ground plus 6 or 7 floors to set it up. CapEx savings also today on the two-phase immersion cooling available. This is the one-phase immersion cooling systems. Basically what it does, it is one phase. So it is pushing cold liquid at the bottom of the tank where the server is immersed, and it is cooling up all the chips, and the hot liquid is getting out. So it's basically a push mechanism. You require an adiabatic and you require a CDU in this case, unlike the two-phase immersion cooling. It is also using oil-based liquids to cool the servers, which may or may not be conducive to your serviceability immediately because the server has to be dried for some time when you go into the one-phase immersion cooling. Over here, the compute capacity would be approximately 100 to 120 kilowatts, and the overall efficiency of the system would be between 1.2 to 1.3 PUE. Just a total cost analysis of how these systems work. So everyone thinks that two-phase immersion cooling, direct to chip, and one-phase are costly compared to air cooling. It is costly in terms of capex, but when you take it as a total cost of the entire project, because you're able to compute more and more heat rejection in a smaller space, your total cost is actually not very different. This is an example done by Open Compute for a tropical climate like India. So if you see the total cost analysis for two peak immersion, one peak or a chiller system, you will actually see that the capex is nearly the same. Plus you see the OPEX savings is beyond measure. So in year one itself, you are breaking even with immersion cooling or direct to chip solutions compared to air cooling. With the compute in today's world going higher and higher, 2 years ago I was in this industry, we were talking about 20 kilowatt racks. Today we are talking about 132 kilowatt racks. In 2 years time, with the new GB200 chip, we are going to go even higher, up to 200 kilowatts. How do you cool this? The only way to cool this is through liquid cooling. So I would urge all of you to come and experience some liquid cooling technologies we have demoed over here, and actually get your hands-on experience on immersion and direct-to-chip cooling as well, to understand how the functionality and the physics of this system work. Any questions, let us know, and I'm here and my team is here to help you all out with anything into liquid cooling and all questions about liquid cooling. Thank you. Have a nice day.